Hello everyone. So I will be solving yet another LeetCode problem. It's an easy LeetCode problem, and this problem is listed in LeetCode 75 aggregated list of questions. So if you are interested, do take a look. These are all important 75 questions selected by LeetCode. So I'll be solving maximum depth of binary tree today. So let's read the problem set. It says given a root of binary tree, return its maximum depth, and then it defines what a maximum depth is. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. You might ask what leaf nodes are. So leaf node are essentially on the edges of the tree. So 9 is a leaf node over here, 15, 7 is also a leaf node, because they essentially, the definition is that a leaf node is essentially the node which does not have left or right a child attached to it. So, and these 9, 15 and 7 satisfies these conditions. So leaf nodes are essentially the bottommost nodes of a tree. Okay, so let's take this example. In this case, we need to find the maximum depth, right? So maximum depth is always measured from the root of the tree, and let's just define the problem in a way that we'll be finding levels, and through that levels we'll calculate the depth. So if we ask, hey, what level are you? So 9 does not have any sub trees, left or right sub trees, so this is at level 1. And then 3 will ask, okay, 9, you are at level 1, then I am on level 2, because it will just add one level. So depth of 9 is 2. And same thing if it wants to know what's the depth of this leaf tree. So 3 would ask, hey, what level are you on? So since it does not have any child nodes, it would say I am level 1. 15 will return level to 20, and then it will add 1 to it. It would say, okay, if you are on level 1, I am on level 2. And then 20 will return, hey, I am on level 2. So 3 will essentially add to it. So we'll say, okay, so 15 is essentially 3 depth below me, right? Because this is level 1, this is level 2, and this is level 3. And simultaneously we can also find for 7, and 7 is going to be again 3, because 7 is going to return 1 to 2 20, and 20 is going to return level 2 to 3, and 3 will add 1 to it. So this is also on third level to it. So the maximum would be, let's calculate once again. So 9 is one level below, so the depth is 1, and the depth of 15 from 3 is 3, and depth of 7 from 3 is again 3. So the maximum of 133 is 3, and hence the answer is 3. And let's take a look at example 2. So I think the graphical representation, I need to I've actually solved it, so that's why it just says accepted, but never mind. Let's go and take a look at test cases. So this is the test case which they are talking about. In this case, how many leaf nodes are there? There is just one leaf node, right? So it's gonna say I am at level 1, and it will return the level 2 1, and 1 will add to it, so the level is 2, and hence the answer is 2. So that's essentially I defined the problem. So what we need to do is, this is a classic recursion problem, and if you have recently started learning about recursion, this is a really good example of a recursion problem. And yeah, so let's dive right into it. For a recursion problem, we need to find a base case, right? So base case is essentially the bottommost case. What if it reaches 15 and then it tries to traverse back? No, or it traverses left and right. There does not exist any child, right? So the base case is, what if we reach the end of the tree? So if root is null, then we just want to return 0, right? Because like, if we ask the child of 15, what level are you on, it should return 0, because it does not exist, right? And then we will be, since we will be recursing both left and right subtree, we will save the depth of it. So let's save the depth of left subtree in left depth variable, and we will recurse next depth, and then we are recursing the left subtree, right? And then same thing will happen for right subtree. We'll save it in the variable right depth, and we will call recursive function root right And then once we have the depth from both left and right subtree, so for 3, if we know the depth of left subtree, right subtree, we are just going to return the maximum of both. Whichever is max, it will return that. So left depth and right depth, and then we are going to return this. So let me explain once again. So what's going to happen is we'll recurse, first of all, we will recurse till end of the tree. So once it reaches the leaf node, it will start calculating the maximum of left and right subtree. In this case, it does not exist, so it's going to be 0. So, and then, oh, I forgot to actually add 1 to it, because that's how we are going to know, right? Since this returns 0, now if it returns 0 back to it, so we know that 9 is level 1 now. So that's why we added on the left depth, we have added 1, and then we are recursing to it. So we know that since it has returned 0, this is level 1, this is going to be level 2. And so for root 3, the left subtree depth is 1. And simultaneously we'll do for 15. 15's children return 0 because they are null, and then 15 returns 1 to 20, and 7 returns 1 to 20 again, and the max of 1 and 1 is going to be 1, and then 20 will add 1 to it and then return back to 3. So it's going to be 1 plus 1 2, 20 will return 2 to it, and 3 will say, okay, now I need to find the max of left subtree and right subtree. So left subtree has 1 and right subtree has 2, so it's gonna say, okay, 2 is greater, so it's gonna add 1 to it. So 2 plus 1 is 3, and so the answer is 3. Okay, let's try to run it. Okay, it passes both the test case, and we submit later. So yeah, it's a pretty easy problem, but you need to just imagining recursion is a little bit harder. So I would say practice more and try to visualize this. It is, although it's like 4 lines of code, but it's very important for you to understand how recursion work, how to set up a base case, and how to write the condition, and then the return part of it. Although it's a easy question, but yeah, you should definitely know this before you start to approach any other tree questions, because most of the tree questions are encountered using recursion. So you have to make sure that you understand the recursion first. Okay, thanks a lot. I will see you guys in next video.